Now we've spent 2 days on graphing sine and cosine, and we're just going to hammer out the other 4 pretty quickly. They tie closely to sine and cosine, at least the secant and cosecant graphs do. Tangent, cotangent, kind of their own thing. You can put these on your master sheet if you have a master sheet of all of the 6 trig functions, or you can just add them in your notes, either one. Let's talk about the parent graphs of a tangent and a cotangent. We always go back to the unit circle. Let's pick out the key points, the easy ones for tangent. If you think about on a unit circle, remember that it was always 0 at 0 and at pi, and at 2 pi. It was always 0. But when it was up and down, that's kind of a messy point, when it was up and down, like at pi over 2 and 3 pi over 2, it was undefined. On a graph, undefined can mean different things, and I should preface this with, remember that we did all of this in class. We did it on Google Drive. We looked at the points, and we actually looked at a whole bunch of points plotted, and what we learned is that at that pi over 2 and 3 pi over 2 spot, there's going to be an asymptote. That's why it's undefined. Now it may help for me to extend this so you can kind of see what's going on over here. But every 2 tick marks on my graph, something's happening. It's either a 0 or it's an undefined. 0 over here is going to be undefined. If I were to back this up, I'd have an undefined right through this tick mark here. The other thing then, as we plotted all those points, what we learned is that they create kind of this nice little curvy wave. And it looks like this. It comes up and then kind of curves on up like this. And then that repeats. It keeps doing the same thing. Approaching those asymptotes. Let's jot down some information about this. The period of it. Well, notice that it just has this wave. That's one period, and it just keeps repeating that wave. But the distance between one asymptote to the next, or from an x-intercept to an x-intercept, you can see is only pi units. This is new. The period of a tangent is pi. Now when we talk about this, the positive slope, it's just so that you recognize which way this is leaning, and it goes upward towards the positive side. Starts at the y-axis right here with an intercept. Then we went and looked at the cotangent function, and it was very similar, but kind of the opposite of tangent. If you think about it, it's the reciprocal of tangent. Everywhere that tangent has a 0, cotangent has an asymptote. And everywhere tangent has an asymptote, cotangent is going to be 0. And the waves actually all go the other direction. It still looks like a wave, but it goes more with what seems to look like a negative slope. The period, you can notice, is still going to be pi units, has that negative slope, and on this one, rather than starting with an intercept, it starts with an asymptote. Let's talk about a couple key things that are different with tangents. The parent period of tangent and cotangent is pi. That's new for us. It's been 2 pi for everything. Well, for sine and cosine. It's now pi. And remember that the amplitude is half the height of the wave. Well, if you'll look at these waves, they go on to infinity and down to infinity. And you can't find that distance, first of all, so you sure can't find half of it. Therefore, officially, there is no amplitude for tangent and cotangent. Now, of course, if there was an a value, it would still affect, it'd be a vertical stretch, and it would affect that graph, but we still wouldn't name it the amplitude. Let's look at the other two. We got cosecant and secant. They are also reciprocals. Now, sine and cosine never had asymptotes, which means that the reciprocal of the asymptote is going to end up being 0. That means that cosecant and secant never ever will touch the x-axis. They won't have any zeros. However, sine and cosine did equal 0 sometimes, which means the reciprocal of that would be an asymptote or an undefined. We will find there are asymptotes on cosecant and secant. Maybe we should start with that. On cosecant, it matches sine. Sine is going to be 0 anytime that I am up 0. That would happen at 0. That would happen at pi. It would happen at 2 pi. All of these places, the sine value is 0. And to be honest, here's what I'm going to do. I'm actually going to graph a sine wave so you can kind of see the comparison. And then we know that the sine wave would go up 1 and down 1. It starts here, goes up, comes back and crosses. There's a nice sine wave. It also goes negative. You can extend it this way also. That's what we know. We know that that's a sine graph. What happens with cosecant, it's the reciprocal. Every time that sine is 0, cosecant is going to have an asymptote. Let's put asymptotes in all of these places. The other thing that's kind of special about them is that the sine value equaled 1 a lot of the time. Well, if you do the reciprocal of 1, you still get 1. There are some values that the sine and cosecant have the same value. And that's going to happen anytime your sine value is 1 or possibly negative 1. Sine, if you're thinking on your unit circle, and we always are, think on that unit circle, sine is going to be 1 right here at 90 or at pi over 2. And it's going to be negative 1 down here. Now if I do the reciprocal, it's not going to change it. It's still going to be 1 up top and negative 1 down below. On cosecant then, at pi over 2, it's still going to be 1. This spot will still be plotted. And at 3 pi over 2, it's still going to be negative 1. That spot's still plotted. And that's going to happen at all of your maxes and mins. That's still going to be plotted. What it is, though, and we saw this when we graphed a whole bunch of points, is it creates these kind of U-shaped things that come down and approach that asymptote, but then they touch right there, and then they turn back around. Remember, we talked how there's not going to be an x-intercept. That's what's going on right here. It touches right there, and then it flips around. If it helps you, you can graph the sine wave. Actually, before we move on this, though, let's talk about one other thing. Let's talk about those 4 features. If you look at amplitude, remember that's half the distance between the min and the max, and since these go to infinity, just like tangent goes to infinity, I can't really find an amplitude. The a value will affect my graph, but I don't have amplitude. The other thing that I want to talk about is the period. What would the period be for these parent graphs? It's not every asymptote, because you have a down U and then you have an up U. Those are 2 different parts of the graph. It's not until you start your down U again that you would have that repeating. And if I look right here at my x-axis, I have this asymptote, and I come back with an up U. This asymptote is fine, but now this is a downward one. Now I'm back to here, and I would go with my up. It looks like it's a 2 pi. Well, it's going to match whatever the wave period is. The parent period for cosecant and secant is going to be 2 pi. The tangents are the only ones that are different. Let's start off and let's try graphing a tangent graph. Ignore this box up here in the top right corner that says what's the parent period of sine and cosine. Doesn't really matter. We're doing tangent. You could answer it, what's the parent period of tangent, and hopefully you say pi. Let's go through and find our features first, and then we'll look at graphing it. Recall that there is no amplitude on tangent because it goes off to infinity. My official answer would be to say none, but that -5 of an a value is still going to affect my graph, so I kind of put it as a side note here I am going to have to pay attention to that A value. The period of this graph. And I should have mentioned, normally we start by factoring the B value out, which we could of course do, but since there's no number being added or subtracted in those parentheses, it doesn't matter if you factor that B out. It's still going to be a 1/2 and there's nothing else to worry about. When you do the period, recall that it is the parent period over B. The parent period for tangent is pi, and I'm going to divide it by 1/2. But dividing by 1/2 is the same as multiplying by 2. I end up with a period of 2 pi. There is no phase shift, there's nothing in those parentheses, there's no vertical displacement. And then you pick your starting point. For tangent, if you look back at your parent graph, tangent has an x-intercept. That's how it starts. Since I don't have a phase shift, I might as well go ahead and plot that point right there. Now the next time I'm going to have an intercept is going to be the period length. 2 pi units later, I'm going to have another x-intercept. 2 pi later, another one. If you're looking at your parent graph, you can see that between the intercepts, you have asymptotes. So find that place and put in asymptotes. And then we're pretty much ready to sketch that wave. The only thing we have to watch out for is that this A value here is going to do some things. Our nice, pretty, positive slope waves are actually going to get reflected. They're going to actually flip and go like this, which is going to make it look like a cotangent graph, but that's okay. And then the 5 is a vertical stretch, so our nice wave here that kind of flattens out and goes on is going to have some vertical stretch to it and not be quite as wavy and straighter looking. Let's go ahead and sketch it. We don't get too worked up about exact points on this. Make sure everything gets placed appropriately and sketch it in. That was a tangent graph. Let's look at a cotangent. This one has some different things in there. Let's go ahead and find our features. I don't have a B value on this one at all other than 1, so I don't have to worry about factoring that out. It's not going to affect anything. I do have this A value of 2, but officially my answer is that I do not have an amplitude. In parentheses, A equals 2. I'm going to have some vertical stretch going on. The period is the parent period, pi, over B, which is just 1. My period isn't going to change. It's still going to be pi units. The phase shift is what's in parentheses. Looks like I need to go left because of the plus sign. Pi over 2 units. And I don't have any vertical displacement. Looking at your parent graph, what happens at 0 at the origin? What's your initial thing for a cotangent graph? And you should say, well, it's an asymptote. We have an asymptote at 0. The only thing is that we have this phase shift. That asymptote is going to get moved left pi over 2 units. Let's put that in there then. And then the period is 1 pi. That means that I'm going to see that asymptote happening again pi units later. And every pi units, or 4 tick marks, however you want to do it, you're going to have an asymptote. If you look back at your parent graph, between every asymptote, you should have an x-intercept. Now this is a cotangent graph. Remember, cotangent weaves in here and has kind of a negative slope looking thing. And the A value is a positive 2, so it won't flip, but it is going to stretch a little bit. And so forth. Let's try secant. Secant matches with cosine. when I see an equation that has a secant in it, I'm really looking at it almost like it's a cosine, and I'm going to graph my cosine first, very, very lightly, and then over the top of it I'll do the secant part of my graph. I'm actually going to change colors. You do it very, very lightly. Officially, my amplitude is none, but I have a negative that's going to reflect over make my graph reflect over the x-axis. I need to remember that. The period is going to be the parent period over b. For secant, the parent period is 2 pi, and b is just 1, so I'm just going to have 2 pi. Phase shift looks like it's going to go left, pi over 2, and no vertical displacement. Right now I'm going to look at it like it's a cosine graph, and if you'll recall that cosine starts maxed out. Oops, right here at 1. Now let's see what's going to change here. I have phase shift going on. It's going to be moving left, but it's also going to reflect because of this minus that's in the front. My maximum that I have right here is really going to be a minimum after I reflect it. It's a minimum, and it's going to have to go left pi over 2. That spot right there is my new spot. And I'm going to make this pink because it doesn't really count as my graph. Now the next time I'm going to be there is going to be 1 period later, and a period is 2 pi. That's way down here. 2 pi units later. It's 8 tick marks. And then I could do it again right there. Those are my minimums. And in between all the minimums, I'd have maximums. Let's go ahead and put those in. Between the max and the min, I'll have an x-intercept. Now, to be honest, you really, if you could just get these points in here, you really don't even have to plot the wave. If it helps you, you can, but just remember, you can almost see the wave sitting there. Let's just leave the dots, and let's go ahead and then graph our official secant graph. Anywhere that cosine was 0, secant is going to have an asymptote. And then I make the U-shapes so they touch those dots that I have plotted already from cosine. What was that? It looks like a penguin or something. Let's see if I can erase it. Yep. There we go. Let's try one more. Let's do the cosecant graph. A cosecant is going to be like a sine. It's going to match with sine. Finally here it looks like I got a b value I got to deal with. Let's rewrite this equation and factor that b out. Dividing by 1/2 is the same as multiplying by 2, which is going to turn that into just a pi. Let's go fill in everything we know. The amplitude officially is none, but I do have that -1 I'm going to worry about. So A is equal to a -1. The period is the parent period. For cosecant, that's 2 pi, but I'm going to have to divide it by my b. Dividing by 1/2 is the same as multiplying by 2. My period is going to be 4 pi. The phase shift I look at after I've factored the b out. So not this, but this. It's going to move left pi units. And I don't have vertical displacement. I'm going to start off and think of it like it's a sine graph, and remembering that sine starts at 0 and heads up. If I start at 0 and head up, that's my starting point, but then I'm going to look at this and say, well, I have a -1. That's going to reflect my graph. Instead of me being at 0 headed up, that's going to reflect downward, and it's going to look like I'm at 0 headed down. I can't really reflect the 0, it lands in the same spot. But my nice sine wave that looks like this normally is now going to be the reflection of it at 0 headed down. But I have a phase shift going on, and I have to go left pi units right there. That is my starting spot. And I am going to be there headed down and not repeat until 4 pi units later. That's way, way later. I'm at negative pi. 4 pi later is going to be at 3 pi. This is going to be way stretched out horizontally. And my graph, if you think about it, is going to look like this. Right? What happens right between those two dots I plotted? Well, hopefully you see there is another dot, another intercept. And then to match that, I know that I need to be down here, minimized. And then on this one, I'm going to be maximized. And you kind of just follow that path. And again, you can sketch this, or you can just look at the dots, either way you want. This time I'm sketching it. Last time I just left the dots. Now, you graph that very, very lightly, because that's not really my graph. My graph is really the cosecant graph that goes with it, which is putting an asymptote at all of the intercepts and making the U shapes come down and touch the max and min of the sine graph. All right, there it is. I guess I can go one more over there, sort of-ish, like that. All right, give it a shot. Good luck.